So in this video, I'm just going to review some strategies when you're working with applications of quadratic equations. So this video is really meant to be like a review for my pre-calc students. So we're just going to jump right into this. So find two pairs of two consecutive integers whose product is 156. Okay, so like it might not be obvious that this comes out as a quadratic, but you have to play around with this a little bit. So the first thing you have to think about is just two consecutive integers. So what are two consecutive integers? Can you think of two consecutive integers? That would be like 7 and 8, or -10, -9. So those are consecutive integers, one after the other. And the thing that you notice about them is that to get to the next integer, you just add 1. So that's very important to notice so that you can figure out how to actually set up this problem. So let me erase all that. So x is going to be the first integer. We don't know what it is, so we'll just call it x. And so what would the second integer be? How would I represent that? If I want to represent it in terms of x, it would be x plus 1. Here's my second integer. All right, so now I have a way to represent the two integers. So if I take the first integer times the second integer, what should that equal? 156. And so now I have a little problem here. So I can go ahead and distribute. So this becomes x squared plus x equals 156. And now I can see that this is definitely quadratic. And a lot of times with quadratics, what we like to do is we like to have them equal to 0. So I can subtract off that 156. And so now this just comes down to, can I factor this? Now, you might have to play around with this a little bit to figure out how to factor this, but this does factor as x minus, let's see, x minus 12 and x plus 13 equals 0. And so then I get two solutions, x equals 12 and x equals -13. Okay, so you're probably noticing then there's a big issue with this. These are not consecutive integers, right? We don't go 12 to -13. But this actually gives us a hint as to what the two consecutive integers are. So notice if I take 12 and just plain old 13, that does equal 156. And if I take -13 and then add 1 to that, -12, that also gives me 156. So we did actually find the two pairs of two consecutive integers. So we just had to think about it a little bit. Okay, so let's look at another one. So you want to buy a rug for a room that is 18 feet by 26 feet, and you want to have a uniform strip of floor around the rug, and you can afford 384 square feet of carpeting. What dimensions should the rug have? Okay, so this is like a standard math problem, but I always think these are kind of funny because like I don't know of any scenario in my life where I was like, I can only afford 384 square feet of carpeting, but you know, like I want to go through it with you guys, but like sometimes I think these are kind of funny, these scenarios, because I'm just like, what? I can't think of a time I've ever actually done that. Okay, so anyways, that aside, so the situation here, can you draw the situation? Maybe like pause for a second, just draw the situation just to make sure you've got it, and see if you can set it up. You know, I'm a big fan of saying, you know, math is not a spectator sport. Pause the video, try, and you'll get more out of it. All right, so I got a room and I got a rug, and I want this little strip around the rug to be uniform. So from here to here, this is x, and from here to here, this is also x. Now, the thing I know about the room is that the room is 26 feet by 18 feet. So here's kind of the situation, right? And so let's see, maybe just to finish marking this off. So this is x, and this is also x. So I've got that uniform strip around it. Okay, so I can afford 384 square feet of carpeting. So if this is the situation that I want, so I need to be able to describe it. So the rug going this direction here, that direction is 26 minus 2x. So this whole side is 26, but then I need to subtract off 2x for that little amount that goes around the rug. And then the other side, so this is 18 minus 2x. So if I multiply those two things together, I want that to come out to what? 384. I'm running out of space, so I just continued it that way. Okay, so now, I mean, I think you can at least see like how we need to finish this. So we need to FOIL this out and then, you know, solve it. So maybe you want to pause here and try that on your own. So I get that this comes out to 468, let's see, minus 36x minus 52x plus 4x squared, and that's going to equal 384. So I can see that this is quadratic. So let's see, this becomes 4x squared, let's see, minus 88x plus 468 equals 384. And then, you know, just as best practices, so usually we want to have this equal to 0. So I'm going to go ahead and subtract off the 384 like you see here to get this is 4x squared minus 88 plus 84. Okay, and so now this is the quadratic that I need to solve. So you might notice that I can factor 4 out. So that's pretty cool. And then, can I factor this? Totes my goats. So let's see, this will be 4. This will factor x minus 21, x minus 1. So I have x equals 21 or x equals 1. All right, and once again, so it's an application, so now you have to think, what does this mean? So remember, the units here were feet. So I actually have a choice here to make. I can either choose x equals 21 feet or x equals 1 foot. So x cannot be 21 feet because that would exceed like the room. So this little border around the carpet is going to be this x equals 1. And so then we just have to figure out the dimensions of the carpet. So the dimensions of the carpet then, so if I take 18 minus 2, this side will be 16, and then if I take 26 minus 2, this will be 24. So the dimensions of the carpet are 16 by 24. So, you know, sometimes when you are solving applications, like I think the thing to really get out of applications, yeah, sometimes they're kind of like silly, like 384 square feet of carpeting, what? But the thing that I think is important for your skill set is being able to interpret what do you do with this information, and like this 21 doesn't make sense. So it's taking that extra moment to think like what actually makes sense in the situation. That's a real world skill that you need, regardless of the fact if we're asking about 384 square feet of carpeting, which makes no sense. The other part of it is actually the important part. All right, so I've got one more here. So the area of a square is 24 more than its perimeter. Find the length of a side. Okay, so we've got a square. The thing about a square, right, is that all sides are the same. So I know if I add up the 4 sides, I get the perimeter. Now, I'm being told about the area and in terms of its perimeter. So I think this is a really good one for you to like pause here and see if you can set this up. You'll get more out of the review if you try that. Even if you get it wrong, it's totally fine. Nobody's gonna know, right? But you'll remember more why this works. If you thought about it, tried something, whether it works or not, doesn't matter. You'll learn more that way. Okay, so the area of a square, so what is the area of a square? The area is, so if I think about this, that's x times x. So the area of a square is x squared. And then the perimeter of the square is x plus x plus x plus x, which is 4x. And I'm being told that the area of the square is 24 more than the perimeter. So the thing to know about the word is in math problems, this always means equals. So I can actually pretty directly translate this. The area of a square, which I said was x squared, it is. So that's boop, equal sign, boom. 24 more than its perimeter. I know what the perimeter is, 4x, and then I add 24. Boom, done. Okay, so now I want to subtract these off and set them equal to 0 because, you know, it's a quadratic, so I want to see if I can maybe factor this. And then can I factor this? I think I can factor this. Let's see, this becomes x minus 6, x plus 4 equals 0. So I get x equals 6 or x equals negative 4. So which one of these actually makes sense? That guy right there, x equals 6. So the sides must all be 6. Okay, and so this is just a short and sweet video just to review some of the techniques you could use when you're working with quadratic equations and applications. So hopefully that was helpful. Any questions, you can always drop me a comment or you can DM me or whatever, and I will talk to you guys next time. Thanks for watching.